Hello guys, welcome to my YouTube channel. In this video, we will see how we can build a machine learning system that can detect a person has Parkinson disease or not. This project comes under healthcare domain. Healthcare is one of those fields where machine learning can contribute a lot. We can use this machine learning technique to diagnose and find certain diseases early so that the treatment can be started soon and the patient life can be saved. So let's see our problem statement. So this is there is a medical institution and we are doing several research on Parkinson disease. How can we detect disease early and start early treatment? And using machine learning technique, we can achieve this. So we have to build a machine learning system that can detect Parkinson's disease depending on certain medical parameter and procedures. So Parkinson disease is a progressive nervous system disorder that affects movement, leading to shaking, stiffness, and difficulty with walking, balance, and coordination. Parkinson's symptom usually starts gradually and get worse over the time. Mostly, it affects people more than 50 years of age. So let's see the workflow. So first thing we need is the Parkinson's data to train our machine learning model. Data contains certain details about patient who has Parkinson's and those patient who does not have Parkinson's. Our machine learning model can find the patterns in this data and it can understand what are the symptoms can be found in people who have Parkinson's and what are the symptoms are common in people who doesn't have Parkinson's. So using this data, our machine learning model can detect this particular disease. Once we have this data, we need to process this data. So we cannot feed the raw data to our machine learning model. So we need to do some processing. And so once we do the processing, we need to split this data into training and test data. We use this training data to train our machine learning model. For this project, we will use support vector machine classifier algorithm. So once we train this SVM model with the training data, we will then evaluate this model using the test data. So once you evaluate your model, we will have a trained SVM model. So when you give a new data, this particular model can detect whether a person has Parkinson's or not. So like we will be using a support vector machine classifier. So like it is, let's say this is the uh, this is 1 and this is 2. So 1 and 2 are the vectors. Vector are the support vectors are data points that are very close to the hyperplane. So like these are two vectors, 1 and vector 2. So if the location of this support vector change, the hyperplane also changes. So and when you give a new data point, it will try to find in which side the new data points belong. So this is the working principle of SVM classifier. So it tries to find a separating line. You can see this is a separating line. So it generally tries to find a separating line. So this is the workflow in which we will follow. Let's get into the coding part. So we will be working on doing our coding in Google Colab. So first you have to upload this Parkinson's data. The link I will provide in my description box. So after that, so first we have to import the dependencies. Dependencies are those library and functions which we need for our project. So let's start. From sklearn model selection. we will import the train test split. So again from sklearn, dot preprocessing will import standard scalar. So from sklearn, import SVM, and from sklearn matrix, import accuracy score. So we will run this. So NumPy as NP is useful for making arrays, and pandas as PD is useful for creating pandas data frame. It is generally used to create a structured table. So the standard scalar is for the data process pre-processing. So the data, we will standardize the data in a common range. So for that we are using the standard scalar. So let's start with the data collection and analysis part. So first, we will be loading the data from CSV file to the pandas data frame. So let's start with the data collection and analysis part. So first, we will be loading the data from CSV file to the pandas data frame. So let's start. So we have pd.read. We'll run it. So we have loaded our data from CSV file to pandas data frame. So now let's check the first 5 rows of the data frame. So Parkinson data dot head. So this is our data set, and you can see many columns. So these are like this is the average vocal fundamental frequency. And let's understand more about Parkinson's disease. So what happens in Parkinson's disease is it causes degeneration of neurons in the brain. So this degeneration occurs, there will be a reduced amount of chemical in the brain called dopamine. So when this dopamine amount is reduced in the brain, there are several processes that will be affected in the body, and people tend to have several movement disorder, like they would have tremors and other difficulties in walking. So these are certain parameters. So now let's check the number of rows and columns in the data frame. Dot shape. So you can see that there are 195 rows and 24 columns. So let's get some more information about our data set. So you can see that there are 24 columns. So many columns are of float, and the status column is in integer, and rest all are float. So name is the object column, so like it's a categorical value. So let's check, is there any are there any missing values in each column? So Parkinson data is null dot sum. So you can see that there are no missing columns in our missing rows in any of the columns. So we have a clean data set. So let's get some statistical measure about the data. So that we will do by using describe function. So you can see the rows like and the count, the mean, the standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and the maximum value of each column, and as well as their of each column, you can say. So now let's check the distribution of the target variable. So our target variable is the status column. So this is our target variable. So Parkinson's data. So status. We'll check the distribution of our target variable. So we will use the variable value count function. So value counts. So you can see that one indicates the Parkinson's is positive, and 0 indicates the person is healthy. So 1 represents the person is suffering from Parkinson's disease. So there are almost 147 data sets of a person having Parkinson's positive, and there are 48 rows which have healthy people data set. So now we will group the data based on the target variable. Parkinson data dot So you can see that we are grouping the status column. So why we have done this? It's because we should know the difference between the people who are healthy and the people who are having Parkinson's disease. So by doing this, by grouping this status column and finding out its mean, so you can see the difference. So the person having Parkinson's disease have like lower this MDVP, and you can see this one is also lower. So kind of everything comparatively, we can know a healthy person, how healthy person's parameter look like, and the person having Parkinson disease look like. So for that, we have done this step. So let's start with the data pre-processing part, and we will first separate the feature and the target. So we'll keep our feature in X. Drop. The name column is not required, and so as the status column, because it is it's our target column, so it's also not required. So x is equal to 1. So now we will keep our target column in y. So we will run this. So now we will print a value of x and y. So this is the value of x. Let's check the value of y. So now we will proceed with the splitting the data to training data and test data. So x train, comma x test, y train, y test, we'll use train test split. We'll pass the our x value, our y value, and we'll pass a test size. Let's say we will take 0.2 and we'll pass the random state. So basically test size is 0.2 means like 20% of the entire data set is taken for the testing purposes and the remaining 80% is taken for the training purposes. So random state equal to 2 is generally it's used to reproduce the same code, like the way it's splitted for me and you will be the same. So it's better to keep a random state with some value. So it's basically used to reproduce the same code. So let's check the shape of our training and test data. So you can see that our original data set contains 195 rows. So it's now splitted into training and testing. So 156, that is our 80% of 195 is 156 is used for training purposes. And rest 39 is used for the like 20% of our original data set. So that is 39 is will be used for our testing purposes. So before proceeding to model training, we have to like the data we see is like it's not a standardized one. Like all values are like in a wide range. So we have to we need to convert all the values in a common range for better pre-processing of data. So we perform standardization. So for that, we will use the standard scalar function. So scalar equal to our standard scalar. So we will fit the data into the scalar, our training data into the scalar. So it's done. So now we will this means we will keep this after doing the standard standard scalar function. After doing standardization of data, we have to transform the data to complete the entire standardization process. So let's keep it store it in Xtrain. So our standard scalar data, we have to transform it first. So scalar.transform. Our Xtrain. Same thing we will do with our Xtest. Scalar.transform. Xtest. We'll run it. So now let's check the value of our Xtrain and updated Xtrain. So print. So you can see the like our data set has been standardized. So within some fixed common range. So now let's proceed with the model training part. So we will be using support vector machine. So model equal to svm dot svc. We'll pass kernel, and you can see the kernel by default it is showing RBF. So we will be using the linear one. We'll run it. So now we will proceed with the training our SVM model with the train data, it's training data. So model.fit xtrain ytrain. So our model has been trained. So now we will proceed with the model evaluation part. So we will be using the accuracy score. So X train prediction is equal to model.predict X train training data accuracy accuracy score will pass ytrain and the xtrain prediction So we'll run it. So now we will print the accuracy score after training data. So let's check the accuracy score on our training data. So our accuracy score is coming out to be almost 88%. So which is quite good. So let's check the same with our testing data. So I will copy this. So instead of train, we have to write the test. X test prediction, X train predict. So here the test data accuracy, our Y test, and the X test prediction. So now I will print the accuracy of the testing data. So our accuracy on the test data is 87%. So which is quite good. So let's start building a predictive system. So input data equal to, here we will take a randomly take a value. This is our data set. So we'll take a value. You can see the same data set is here. So our status column is in between HNR and RPDE. So I will randomly copy value. Let's say this one. I will paste it here. So I will remove this name column and we'll remove the status column also. So status column is in HNR, between HNR and RPDE. So where is this HNR? So this 1, 2, 3, 4, 5, 6. So after 1, 2, 3, 4, 5, 6. After status column, it's 6. So one, 2, 3, 4, 5, 6. And this is our status column. So this I will remove. So I'm removing the status column as it is our target column. So now let's change the input data to NumPy array. Put data as NumPy array and p dot as array will pass input data. So now we have to reshape the NumPy array. So input data reshaped equal to input data as NumPy array dot reshape. So we'll pass 1 comma -1. So as we are training with only one particular row, that is one particular data set. So I'm reshaping the NumPy array for accordingly. So now we have to perform the standardization. This is the raw data. So remember that we have while training our model, we have standardized the data set. Even during the testing our model, we have tested on the standardized data set. So our model is trained for the standardized data set. So we have to standardize the data. चलो तो transform input data reshaped. So now we will start our prediction. So we will fit our model dot predict will on standardized data, and we will print our prediction. So I will give a if statement indicating the person is having Parkinson disease or not. If prediction of 0 is equal to 0, that means the person doesn't have the Parkinson disease. So I will print it. Print the person does not have Parkinson's disease. Else print the person has Parkinson's. So we'll print, we will run it. So you can see and the result is coming out to be 1. So in our original data set also, we have that the status is 1. So our model is predicting well. So here's how we can detect a person is having Parkinson's disease or not. So that's it from my side. Hope you have enjoyed this video. Thank you.